Oh gosh, man, the workbench is a disaster, but I put together the bench node here so that we could start to work on doing a few bits more of testing. We've got the Tesla M40 in here along with three 4060s, not that we're going to use them all today, but we're going to answer a few questions. Well, one question that turned into a deeper question, and these are the two questions. They're basically the same. I think we should go ahead and move on into the lab and away from these noisy heat generators in front of me and go see if we can put some answers around this. Welcome back to the lab, robots. Today we are going to do the testing from the viewer questions that actually lead to a much more advanced topic, which is how to control these models or the split between two different or mixed GPUs, which is the specific question that we have at hand. Let's just cover the questions again real quick and make sure that we're all on the same page of what we're trying to answer today. At 61free asks, I am realizing the 16 gig VRAM is a bit of a bottleneck though. Do you think adding an M40 or two would help? Will the GPUs be able to crosstalk with each other's VRAM? The answer to that question, absolutely yes. CUDA does not care. As long as you have the GPUs in there, it will split across the GPUs. The bigger question that this asks that you may not realize yet is how do I control the split between GPUs or even mixed GPUs, which turns into an advanced topic around tuning, which is called tensor splitting. We will get into that later in this video just to cover these questions easily. And at 246RS246 also asks, is it correct that a 20 gig model can be run on two 16 gigabyte VRAM cards? Yes, it is. If so, is there any advantage to running the model on a single RTX 4060 card and a Tesla M40 at the same time? Does this make sense? Yes, that makes sense. If you're trying to expand out your context size or run bigger models, you can absolutely run it across mixed GPUs, so a 4060 and an M40. My question that I'll put to you guys before we get into a lot of this testing though is, if we mix a 4060 and an M40 together, where do you think the speeds will fall in? Do you think it'll be as quick as a 4060, or do you think it's going to slow all the way down to an M40 speeds? Now, with that question in mind, and since we are going to bundle off one of the last videos testing where we tested a CPU versus the M40 versus the 4060 versus the 4500, let's go ahead and go back and review those test results just to make sure that we are all on the same page. Now, the most important thing that we always talk about, right, or everyone wants to talk about, is the evaluation tokens per second. So this was a test that we ran in a previous video where we pitted a i9 CPU versus the Tesla M40 versus the 4060 versus an A4500. When we're looking in here, we can see that in orange was the CPU, that was the i9, in red is the M40, green is the 4060, and blue is the 4500. So if we're looking here, the M40 was just under 5 tokens, evaluation tokens per second. The 4060 was just above 15, and the 4500, right over 25 tokens per second. So when we look at the 4060 and we look at an M40, what happens when we combine these two cards together to run the same code stroll 22B 8K context Q4 quant, because we want to keep this the same so that we can compare it to the results from the last video. Go ahead, pause the video, put your guesses down below. What do you think is actually going to happen? Now, let's talk about a little bit about the default of how Llama or Llama CPP, or in my case, I'm running LocalAI, which is basically just running Llama CPP under the hood. In default, if you are not advanced tuning the parameters on your models, it's basically just going to split the model 50-50, and then it's going to load your KV cache onto whatever is your main card or whatever your system detects as GPU 0. We can obviously get into the advanced tuning, which we are going to do in this video so that I can actually show you guys the differences of splitting in between mixed cards and how it can affect you just by simply moving different percentage points, basically, of the model in between your main card and your secondary card, or even more. So let's go ahead and start to set up our environment to make it through. We are going to be going ahead and using the GPU bench node today. I just kind of went through and did a bunch of rebuilding on the labs as I'm setting up my lab for very specific usage for me, not for the YouTube channel, but for my career. So today we are actually going to use the GPU bench. This is an i9-9820. It runs on a Supermicro C9X299-PGF logic board. This is an X299 system. It has 128 gigs of RAM, which really doesn't matter for today's test because we are going to be using VRAM, a couple of SSD boot drives, and 1 terabyte NVMe drive that it uses to store all the models so that it can load them as fast as it can, really. Has 4 PCIe 3.0 x16 slots. It can run at different modes depending on what processor you have and how you have the cards in there. It has 2.5 gigabit networking, 850 watt Corsair power supply, an open air case. It runs in Ubuntu 2304, and it cost me about $926 in total to build this without GPUs. We have other GPUs that are across the lab today. We're only really going to be using the 4060 and an M40 in there. Just in case you guys are curious, I have a bunch of 4060s for sale. If you're interested, reach out to me. Let's go ahead and move on to actually setting up our environments of what we need to test this today. Sorry for all the emails going off in the background. That's just what it is. Alright, so we're going to need to grab a 4060 and an M40 together. So let's go ahead and we're going to split this over, and we're going to grab GPU 0 and the M40, which is GPU 2. We'll hit enter. We're going to go ahead and patch that deployment and let it spin out. And it should come back with just showing us a 4060 and the M40. And there we go. We are going to move over and use the 8K model, the same one as we used at the last test. So remember, this is CodeStroll 22B, 8K context, and a Q4 quant. This is just to keep everything dead even with what we did in the last video so that we can really compare the data. And this fills a single 16 gig card. So we're going to go ahead and select that. In our normal thing, we did 20 in the last test, so we'll do 21 again. Remember, we skipped the very first test because that is unloaded. That means that the model is not loaded into memory yet. So we just want to skip that and eliminate it from our results altogether. In this case, we're going to say 4060 M40 CodeStroll 22B 8K. And we'll skip the result, and let's just go ahead and start this test up. Well, actually, you know what, first let's go ahead and make sure we get the right metrics up so that we can look at everything. All right, I'm going to need GPU 0 and GPU 2. And just to go over again, we have our Grafana Prometheus metrics from the Nvidia DCGM exporter up at the top right. These will lag behind, right? But it'll give us good details. You can watch the power. These will lag behind. Down below, we have NVTop. This will give you very live metrics so that you can watch the CPU and the memory usage across the board. And then over off to the left, we have our application. So let's go ahead and dive into this. This is going to be CodeStroll 22B, 8K context, Q4 with just default settings. And actually, let me double check that. Yep, I have everything commented out on the model. Just default settings on the model, and we'll see how it goes. Splitting in between the M40 and the 4060. Okay, we're going to let this load up. You can watch the memory split in between GPU 0, which is the 4060, and GPU 2, which is the Tesla M40. Remember, this is all in default mode. I haven't changed or messed with any of the settings as far as tensor splits or anything. We're going to let this go ahead and load up, and it should take just a minute here. and start responding to us, and I'll let you guys get a feeling for what it feels like just in default mode of a 4060 and a Tesla M40, and these cards are, you know, a good 6 years apart from each other. And there it goes. And we can see the majority of the memory, well, not the majority, but slightly majority of the memory actually ended up on the Tesla M40. Interesting, huh? So we'll let this go ahead and go. I'll let you guys get a feeling for it on how fast it actually feels, and we'll flip into our normal, you know, light speed, fast forward mode so that you guys don't have to sit here and watch this in real time. And you can see over there that the M40 is definitely working harder than what the actual 4060 is as far as the GPU utilization goes. And let's just go ahead and chunk this into fast forward mode. See you guys after the test finishes. Okay, so as this wraps up, I want to point out that this was completely in default mode. I didn't change really any settings. I just let LocalAI underneath the scenes set it all up and split it. So did you see anything that stuck out to you guys? I'm going to go ahead and name this default just so that we can compare it later. Hit enter. Let's go ahead and produce this report. And let's just go double check our data and take a look at it. And most important thing, evaluation tokens per second. What does that tell you? Interesting. I think the M40 was just under 5 tokens a second, but we'll look at that later. Let's just double check the raw data and make sure everything looks okay. Yep, nothing blinked out. All right, so now let's really talk about this, right? If this is a 4060 that we're normally used to seeing like 15 tokens per second out of and an M40, it lowered it down pretty good. So that just basically makes you think, well, it's going to go as slow as your slowest video card, right? Or as slow as your slowest GPU. Now, if we were to consider this a little bit more, I want to talk about tensor splitting. So depending on what you're using, LocalAI, Ollama, Llama CPP, whatever you're using, should have the ability to pass tensor splits over to whatever server is actually running these. And that gives you the ability to kind of control where you want things split. So this is not normally in the server setup. This is normally going to be parameters for the model that you're running. So I'm going to go ahead and we're going to modify this. And I'm going to go ahead and turn it on. Tell it that the main GPU will be the 01, which will be the 4060 Ti. And then you can see that I have the tensor split set at 9 and 1. There's lots of different ways that you can set up the tensor splits. You can go read documentation on it. In this example, I'm going to want you guys to think about this as a almost a percentage weight, right? So if I say 9 and 1, I want 90% of this model basically running on the 4060 and 10% running on the M40. So let's go ahead and save that. And again, I'm going to split it because I want the majority of this model running on my fastest card. And let's go ahead and run the test again and see what kind of results we get just by doing that. And then we'll try to split it a few other ways and see where we go from there. All right, I'm going to go grab that same name of the report. So 4060 Let's go back. We're going to cycle the pod to make sure that we get all clean test results. All right, let's make sure we get the right model going, which is the 8K Quant 4. And we'll name this one 9010 so that we know the split. We're going to skip the first result. Going to do another 21 runs. And take your guesses now. And let's go ahead and start and see what this does. So remember, I set the main GPU to be the 4060. And I kind of set the tensor split at 9.1 or 9010 is how we're going to evaluate it in this manner. Again, go ahead and read the docs about the tensor splits. Now we can see that this loaded up, and it looks like almost all of the VRAM, like we said, goes onto the 4060 and very little on the M40 over here. And let's go ahead and feel the speed out of this, because remember the 4060 should have the majority of all of the tensors on it. Feels much quicker. Same cards, just a different configuration, right? All right, let's go ahead and go into fast forward mode. And I'll come back as soon as the test is done, and we'll take a look at some more details. All right. Looking at that, I can definitely tell the difference. Can you guys tell the difference? Let's go ahead and produce this report, and we'll go take a look at it. Make sure all of our data looks good. Make sure we get the right report, 9010. Looks like all the data is there. Let's just take a quick scan. Yep. And hop over and take a look at the evaluation tokens per second. Okay, so remember we split this 9010 in between the 4060 and the M40, and we basically went from what we saw in our last default test all the way up to 12 tokens per second, which is, yes, below what a 4060 will run by itself, but it's still pretty performant considering we unloaded some of that model over to the M40. Okay, so let's go ahead and go back, and we're going to run one more test here, at least one more. Let's do a 70-30 split. And I'm going to go ahead and save that. And we'll cycle the pod to make sure everything is nice and clean for our testing. And again, remember, we're not testing for accuracy, we're just testing for base speed and a general idea. Okay, make sure we get the right model selected, the Q4AK. We've got just our two GPUs. We're going to log this one as a 70-30 split. Skip the first one. And take your guesses how this is going to affect the memory split and the speed that we see. And let's go ahead and get started. We can see it loading up over there. Definitely more of a split across the board. And there it goes. How's it feeling to you guys? Again, remember there's a pretty big gap in between the M40 and the 4060 as far as years of technology goes. And price. Still feels pretty decent to me. Let's do our typical light speed fast forward, go grab yourself your favorite drink or whatever, and we'll let this go, and I'll see you guys at the end of this one. All right, since that test is finished up, I would say let's go ahead and run one more, right? In the default, we saw it split generally what looked to be 50-50, but I want to go ahead and make sure that we run a 50-50 test too. So let's go ahead and produce this report, and then we'll go just check the raw data, make sure everything looks okay. Default 70-30. Show raw data. Okay, that looks generally good. Let's take a quick look at the evaluation tokens per second. Split 70-30 in general across the two cards. As we can see, it dropped just a little bit more, as we would pretty much expect from the testing that we're seeing, right? So let's go ahead and run one more before we bring all of this data together. And we're going to set this to 5 and 5. We'll basically just split this 50-50, right? Save that. We'll go back to our GPU testing. We're going to go ahead and cycle this pod so we can get some fresh logs off of it. And there we go. Let's make sure that we select the right model. 8K Q4KM. We still got just our 2 GPUs. We're going to paste this in, and we're going to call this 50 skip our first results. We'll go ahead and hit 21. Take your guesses, but I assume everyone knows that it's just going to drop down to basically what we saw around the first test. But let's take a look and see. And there you can see it loading up, much more evenly split. Give it just a second here so you guys can feel what it actually like relatively feels like. And there we go. So in total, just remember, like a 4060 at 16 gigs and an old M40 or any of the other older cards, that's, you know, could get you up to 40 gigs of RAM pretty cheaply. Or at least if you've got an old card sitting around, you can add it to your existing card to expand your VRAM out. And then just use, you know, the tensor splitting to be able to put, you know, the majority on your best card. All right, let's do the big thing and let this go into fast forward mode. And at the end, we'll bring all of this data together and take a quick look at how this looks across the board when you're mixing cards. All right, now let's go ahead and produce this report. and start to bring all of this data together and bring this to a conclusion so that you guys can get some information off of it. All right, let's just go take a quick look at that report, make sure everything looks good. Quick peek. All right, looks good. All right, so let's go bring all of this together. Now, I'm going to straight out admit that I realized during the last test that I've had a system prompt set for all of our tests today, whereas our previous video I did not, so our input tokens is a little bit higher. I messed up. That's what testing's for. But we'll go ahead and just bring that along as, in the end, I don't think that's really going to affect the numbers that we're looking at. Mixed GPU Tensor Split results. And we are going to choose the 4060 results from before, the M40. These two are from our previous test. And then we're going to do all of our ones from today. Default, 9010, oops, 7030, and 5050. And let's combine these all into one big report so that we can actually go see these. All right, let's flip over. Go grab that. All right, so across the board we've got blue is going to be the 4060 testing from our previous test. Orange is going to be the M40 from our previous test. Green is going to be the 4060 and the M40 in default mode. Red is 4060 and M40 in 9010 mode. Purple is going to be 7030 mode, and finally brown is going to be 5050 mode. So this is the prompt evaluation time. So this is almost exactly what you would expect. The M40 up at the top taking the longest, whereas you've got blue and red, which is basically almost all 4060 down here. And you can see you can offload like a good 10% without it affecting speed or prompt evaluation time at least all that much. But then this is what you would expect, is as it gets split and goes more and more onto the M40, the slower it's going to take. All right, let's take a look at the evaluation time. Again, this is going to be all over the place because no model is going to give you the exact same response every single time. So those responses are going to differ, and you can almost see how long of the response is based on how long it takes. But again, you've got the just straight 4060 by itself at the bottom and the M40 at the top with the different mixtures right in the middle. Now the next one is total time. This should mimic what we just saw, so we'll go right over it. Prompt tokens evaluated. Remember, I messed up, so the previous two tests, the top ones from 4060 and M40, were 101 tokens across the board, and all of today's tests were 124 prompt tokens across the board. My mistake, but shouldn't really affect our results that we're looking at. Completion tokens. Again, this is almost going to mimic the results from the evaluation because there's going to be different answers coming back each time. It's not going to be the exact same answer every single time that we do this. Looks pretty normal though across the board. They're fairly condensed, so it was giving fairly close answers, at least not for accuracy but for length over the general length of the test. The total tokens, this again should mimic that. And let's go ahead and get down to the prompt tokens per second. This is, the prompt tokens that are coming in and what it's evaluating. Same exact pattern that I would expect. That's a little interesting right there, huh? Okay. Now, let's take a look at what everyone is waiting for, which is the evaluation tokens per second. Now, again, we've got just the straight 4060 right at the top hovering at, just below 15, 16 tokens per second. The 9010 split over to the M40, in between 12 and 14 tokens, and more like 12 tokens per second as it leveled out. And then as we move over to the 70-30 and the 50-50, right, it gets, more shifted over to the M40 and really starts to slow down quite a bit. The green is the default, right? So if you do not set the tensor splits at all, this is basically what you would end up with by default, where it's, going to choose its own pattern of splitting it between the GPUs. And then finally at the very bottom is the M40 by itself, right? So hopefully you guys actually got some details out of this of yes, you can run mixed GPUs no problems, even across multiple generations. Is in this case, this is a 4060 versus an M40, right? And you add those two together to extend out. If you have the point of where you need to extend out your VRAM at all and have an older card sitting around, you could absolutely do it this way, and this would tell you that. The big thing to remember is the tensor split. That parameter on your model is very important depending on your circumstances for maximizing performance. That single parameter can change a lot in multi-GPU setups, right? So unless you want it just defaulting and splitting across the board, you should do some research and testing on your own about how you should have that set up if you're running mixed GPUs and for whatever your actual goals are. All right, the next big thing I want to bring up just before we end on this isn't the only way of doing this, right? So when we're talking about tensor splitting across GPUs, there's also GPU layers of like what you're offloading to the GPU. So you could split your model in between your GPU and your CPU. Is it going to be much slower than splitting it in between that? I don't know, maybe that's something that we would have to test, but I think you would have a pretty good idea about our previous test where we were actually testing CPU versus GPUs and even the M40 there. All right, I'm getting a little hungry, could use some pizza. I'm sure my AI could use some pizza. Let me know what you guys learned from here, and thanks for watching. See you guys on the next one.